Okay, so I'll take the screencast from here because we went over the first and second page together. Even though we did these also, it's worth going over again. So just remember, you have to make sure it's going in the right order. Which shape is moving on to which shape? It's not always smaller to bigger, right? So we talked about OBC had to go on to OLK. So in this case, it is a rotation of 90. Or you could say counterclockwise, and then followed by a dilation centered at the origin of 1/2. You could have reversed it. You could have dilated by 1/2 and then rotated by 90. Either way would work. This one, same thing, you could do it in either order, but I reflected over the y-axis, and then I dilated by 1/3. And again, it's not getting tripled, it's not dilating by 3, it is getting dilated by 1/3 because you're starting with OKBC and you're moving on to OHTR. So after you have reflected, you then dilate by 1/3. How do you know it's 1/3? You could say, well, that is up 3/2 is 1. So there's 3 of those that happened. So it got 1/3 as big when it moved over to that way. Okay, so on number 15, you do have parallel lines, and you know that because that angle is the same as that angle as it's marked there. So if those two angles are the same, then these two lines would be parallel. So now that we know that, you could make similar triangles here because you have angle, because you have those pairs and you have the reflexive angle at the top. So you know you have similar triangles. So if you look at the smaller triangle, you have 6 over y. And then if you look at the bigger triangle, you have 8 over 10. So if I cross multiply, you get 8y equals 60. Divide by 8 and you get 7.5 for y. Remember to redraw both triangles when you're doing that, and the key is to make sure you understand that that whole side is 8. So I erased everything and I'm going to solve for x now. So I still have the little triangle, and the little triangle has a left of 6 and a bottom of x. And then the big triangle has a left of 8 and a bottom of 12. And now I'll cross multiply and solve. 8x equals 72, x equals 9. Okay, on the next problem, the only thing that's a little bit frustrating is the one on the right is turned and twisted a little bit. So you could do this with tracing paper or just redraw it yourself. And if I turn it a little bit like that, now it looks just like the one above it, and you can easily see that 6.5 matches up with 9.75 and 7 matches up with y. So I'm going to do 6.5 matching up with 9.75 and 7 matching up with y. And you can cross multiply and solve there. I'm also going to solve for x. I can set up that proportion right now too. I can go 6.5 over 9.75 and then bottom over bottom. So that would be using the 6.5 over its corresponding 9.75 equals x over 13.5. Cross multiply and solve there. And that appears to be my work after I cross multiplied and solved for y and for x. Again, solving for x and y separately, you can see that the way the angles are at the top and the way the angles are at the bottom that match up, that this is obviously a dilation, but it's also a reflection over that line. So that means that this corresponds with this, and it means that this reflects and corresponds with that, and this obviously with that. So you match up the colors, and you have 8 over 14, and then you can have 5 over x. And if you wanted to solve for y, you can use the 8 over 14 again because you know both values. So 8 over 14, and then go back and do y over 12.25. And that's the work there. You have 8x equals 70, divide by 8 on both sides, and you get 8.75. For y, 14y equals 98, and when you divide by 14, that comes out to an even 7. So I don't want this to become an answer key, so for the next few problems, I'm just going to talk about how to do it so you understand it. This one, this little dot in the corner here and here shows that this is an isosceles triangle. So if that side is 8, then so is that side. So in this particular problem, you have x over 8 and then 5.57 over 8. The answer is going to be 5.57, and you'll see why if you set up the proportion. So it's x over 8 and 5.57 over 8. On the next problem, it's set up the same way, the angle bisector theorem. Because those two angles are the same, meaning that was a bisector, you can just go x over 8 and 15.75 over 18. Then you would cross multiply and solve. This is a side splitter situation. So you have a part over a part equals a part over a part. You're allowed to do that if the lines are parallel and you're dealing with all sides. So you have 2 over x plus 2 equals 2.5 over 10. So it looks just like it looks in the picture when you turn it into an equation. You'll solve from there. Now the next one, this long thing of x has been confusing people. There's no such thing as x plus 10 in this picture. X is already the entire piece. If you wanted to, you could call this little piece x minus 10, although you don't have to. If you did that, you'd have this piece, this piece, this piece, this piece. But what you can also do is say the entire thing over the entire thing equals the bottom over the bottom. So that would look like the entire thing is x over the entire thing on the other side, which is 45.6 when you add it together. And then you go back to the other part and it's little part over little part. And cross multiply and solve that way. Same thing here. There's no such thing as 12 plus x in this picture. 12 already includes the entire distance between those three lines. So I'm going to say the entire part over little part, just like the last problem. So the entire 12 over the entire 14, that's 10.5 plus 3.5, and then go back here and go little over little, cross multiply and solve. This is that catchy situation where you can't use a side splitter. You can only use a side splitter when you're given 4 sides, meaning on the edges, not on the bottoms. You can't use the side splitter theorem when you're talking about pieces that are on the bottom. So in this case, you have to redraw both triangles, which actually will always work if you wanted to do it that way. So you have the left over the bottom of this triangle, and 12 plus 3 is 15, the left over the bottom of that triangle. But you should never have a 3 in any of your equations because the 3 is not a side of a triangle. So redraw 2 triangles and set up the equation. Now remember, I only asked you to find x in this problem to keep it simpler, so don't worry about y and z. So if you look at this, you'll see that the small triangle over here has nothing other than the 4 labeled. So I'm not going to be dealing with the small triangle at all. The medium triangle looks like it has 2 things labeled. The medium triangle has a long leg of 8 and a hypotenuse of x. I'm going to erase that, and let's talk about the large triangle now. This has a long leg of x and a hypotenuse of 12. Cross multiply that block of 4 there, you have x squared equals 96. This is a good practice to break down radicals. The square root of 96 is broken down into a perfect square of 16 times 6. Square root of 16 is 4. 4 radical 6 is x. On the next problem, this is a little trickier because the two triangles in the middle look similar in size, so it's harder to tell that this is the small and that this one is the medium. But we're going to solve for x here, and I'm going to look at the medium triangle right here. The medium triangle has a long leg of 9 and a hypotenuse of 12. And then the large triangle has a long leg of 12 and a hypotenuse of x plus 9. So when I cross multiply, I have 9 times x plus 9 right here equals 144. 12 times 12. 9x plus 81 equals 144. When you subtract 81 from both sides, 144 minus 81 is 63. Divide both sides by 9, and x equals 7. Okay, so I'd rather you listen to my explanations than copy down what I'm writing, so I'm not going to write, I'm going to highlight and talk. This picture has parallel lines. With parallel lines cut by any transversal, you're going to end up with congruent angles. These are corresponding angles because of the transversal. There's another transversal here, so these angles would also be the same if you wanted to, or you could use the reflexive angle at the top. So the first thing you're going to write is your given. You're going to say UW is parallel to VX, given. Then you're going to tell me that angle U is congruent to angle V because corresponding angles are congruent. You could also say angle W is congruent to angle X because corresponding angles are congruent. Or you could say angle T is congruent to angle T because of the reflexive property. You now have at least two angles that are the same, so you can now prove that triangle TUW is similar to triangle TVX because of the angle-angle theorem. Now in this proof, you again have given parallel lines. It doesn't mark it in the picture, but it says it in the information, so we can say that those are parallel. If those are parallel, again we have a transversal here, so that means that this angle is the same as this angle, and it also means that this angle would be the same as this angle because they're alternate interior. So basically, anytime you have parallel lines in a similarity proof, you're probably going to have the angle-angle theorem. So you're going to start off by writing the given. QR is parallel to ST, given. Then you can say angle Q is congruent to angle T because alternate interior angles are congruent. Or you could say angle S is congruent to angle R because alternate interior angles are congruent. Or you also have the option of talking about the vertical angle in the middle. You could name those 1 and 2 and say angles 1 and 2 are equal because vertical angles are congruent. You only need 2 out of these 3 because now you're going to say, doesn't ask you to prove the triangles similar, but you still have to. So you say triangle QRP is similar to triangle TSP because of the angle-angle theorem. And then you're going to write the prove line here, RP over SP equals QR over ST. And the reason is corresponding sides of similar triangles are in proportion.